Prime Minister Narendra Modi inaugurated the Chenab River Railway Bridge last week.
माता वैष्णो देवी के आशीर्वाद से आज वादी कश्मीर भारत के रेल नेटवर्क से जुड़ गई।
The bridge scores many firsts. It is the first time that the Kashmir Valley will be connected with the rest of the country through a rail line. It is the world's highest elevated rail bridge, 359 meters from the riverbed of Chenab, making it 35 meters taller than the Eiffel Tower. It is the first all-weather bridge that connects the valley and the rest of the country. It's an engineering marvel, and somebody who's been involved with this project right from the inception is with me today to talk about that. Professor T.G. Sitharam, who's now the chairman of the All India Council of Technical Education. When he got involved with the bridge, he was working at the Indian Institute of Science in Bangalore. Welcome to the show, sir.
Namaskar.
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 Professor Sitharam, how challenging was it to build the engineering marvel that the Indian Railways today has presented to the country?
This is really a phenomenal, the kind of quantity of work which has happened to build this bridge from inception. See, the time it took itself will explain to you how difficult it is in such a terrain where there were no roads to even go there. That's the kind of a thing. Today, it's really an emotional moment for me, because I have seen myself going there so many times, closing my eyes, sitting in the jeeps there. No cars can go, only the jeeps. And that is, from that time to now, it's mind-boggling. Really a great challenge for civil engineers for the country, and they have demonstrated eloquently that India can build such a large, fantastic structure which is standing tall, which connects Srinagar to Jammu. This is the major, it is not just the rail lane, it is the connection between the two groups of people who are completely isolated. Now it only hardly takes about 3 to 4 hours to reach because of this bridge. This is the key element in the Udhampur, Srinagar, Baramulla link. Very key element. This bridge is playing a major role, and it is at such a height you could imagine the challenges. Not only the wind, and it is in a location very earthquake prone, and geologically the material which is standing there is a very younger dolomite, which is a very weak stone, rock stone. So how do we build, how do we put the foundations on this bridge? This is mind-boggling, and today we are very happy to see the fully constructed bridge, and Honorable Prime Minister launched the train, and train has moved now, but before this lot of testing has also happened. So it's a very phenomenal, I will say, it's a fantastic moment for Indian engineers to see this bridge happening there.
You talk about how the stone or the rock is weak. It's dolomite, which I understand is a younger sandstone. So how safe is it? How potent is it, or how firm is the bed or the rock to take such kind of weight on it, and with a high moving train passing over it?
So dolomite is a younger limestone, and which will have a lot of cavities. And many other things. A characteristic of this particular site was it is highly fractured rock, dolomite. That means the pieces will be very small. The giant spacing would be very small. So in that condition, rock was on its own not able to take the loads of the foundation. Even though the hill itself is such a huge hill, on that whatever bridge is coming is like a small toy. But if you look at the finer details at the every foundation, either on the arch span or beyond the arch span, it has to be taken, the loads have to be taken by the rock. So this dolomite, younger dolomite, could not take the load. So a lot of work has happened in the sense of grouting to improve. Cement grouting has been done. to improve its binding characteristics. And then rock bolts, rock anchors have been used at many places. So
No, are you saying, Professor Sitharam, that you almost firmed up the whole mountain?
almost, very rightly said, almost. Why? Because otherwise there is no way. First of all, the challenge was excavating to the desired depths at which our foundations is going to sit, and then creation of a foundation, and then stabilization of these slopes and the foundation is a big challenge. Because look at those arch and beyond arch also, about almost 1.2 kilometers, the approach ramp is also there. So in all these places the rock quality was very poor. The RQD, what we say in engineering, rock quality designation, was less than 10%. That means it is almost like a soil. So that from there, how do we put these foundation on such a material? That was the challenge for us.
So that was firmed up with cement, you saying?
Firmed up with grouting, I say, because grouting is done to fill up the fractures in the rock. Okay, it is not just at the surface, even at the bulk. And then rack anchors, rock cable anchors are also put to a greater depth to transfer the load internally. Then on the surface, what you talked about is shotcreting done completely, so that there is no erosion due to rain or any other, even due to vibrations, slips cannot occur. The shotcrete also has been done on the surface of these finished slopes.
Okay. It's also an all-weather bridge at such heights. When we're talking about 359 meters, such high mountain passes, huge high velocity winds blow, in the valley it snows. How will this bridge deal with all that? How is it equipped to deal with the weather?
This is an all-weather bridge, and the design is done for all the wind loads, earthquake loads, okay, and the live loads of the train and the train movement and the people as well, which are going in the train and also who are on the surface. So all that has been taken into consideration in design of the foundations as well as the slopes. So this is also, we should also make sure that these foundations are also accessible, because it is a steel bridge which requires maintenance as well. So all these are considered while designing this bridge.
You say it sits on a very vulnerable seismic zone. How safe is it for trains to pass through this bridge?
See, this is in a younger mountains of the world. Himalayas is the youngest mountains of the world. So it's very vulnerable for earthquake conditions. So, but let me assure you, this has been taken care, and it is designed for maximum horizontal acceleration of 0.36 g, which is based on calculations and analysis. Everything has been taken into consideration, and it is safe completely for earthquake loads as well as wind loads, and exactly as I told you earlier, the live loads and the moving train loads.
But what is the 0.36 g for a layman like say me? How much on the Richter scale can this bridge withstand?
The maximum earthquakes can go beyond even 7 in a Richter scale, and that kind of a load can be taken care by this bridge.
So it can withstand a 7
to
Richter.
8 also, 7.5 to 8.
It can withstand without any damage to the...
Without any damage. And also structurally, it has also been taken care. Structurally also, some isolation schemes are put so that it doesn't damage the bridge, even there is a slight movement of the foundation. Okay. Structurally also, the flexible joints have been kept, and it is one of the monumental projects actually executed by Indian Railway engineers. Hats off to them.
Talk to us about the design of the bridge and why is it unique?
See, the design of the bridge was very unique because it's situated, the location of the bridge is in a very difficult terrain. There was no accessibility to both abutments of the arch bridge. Okay, if you look at it, the river is flowing in the valley, and both of the abutments has to take the foundation of this bridge. And both are actually were not accessible at all. There are no roads. First thing, Konkan Railways, even though Northern Railway is the owner, Konkan Railway did a road project to connect both the Riyasi side and the other side, so that there are roads built so that they can bring the material and they can create their operational office, store, everything, because it's a steel bridge. So that was the first job. I actually traveled during that time. As I told you, these roads were no barricades on the both sides, no even finished surface. Only the jeeps, rugged jeeps only can travel. I used to sit and look at like this. It's about 350 meters or 660
That must have been scary.
It is scary. Whenever I used to travel, they were very confident. The drivers were very confident, the local people, but we were scared and looking, closed our eyes, and till they reached both the abutment. After reaching, you see, these foundations are also different levels. So even you have to reach the foundations. And slope also, you see, because the existing 43-degree slope and again 76 degrees the maximum slope on this both sides abutment has to be flattened so that it is stable.
Oh, you're saying the whole slope was
Yes,
cut?
yes,
The rocks were cut
into several steps.
Okay. To give a smooth horizontal
flatter
surface.
slope, so that slope stability is not a bigger issue. On its own, it can also stand without any of these bolting, rocking, and shotcreting and all that. So slopes were also flattened. While flattening, we also created roads to access every foundation for future maintenance. Even first is the construction, and then next is the maintenance. So all these foundations for the arch, span, everything is accessible today by road. Okay, that's a phenomenal again excavations, and which also gave a flatter slopes for my both abutments, left and the right abutment of the river, on which all these pillars have been founded. And foundation itself, there are huge foundations. They are not very what you see in a conventional buildings. They are huge, 40 by 50 meters size foundations, and running up to 10 meters thickness. Concrete foundations have been constructed.
Which are going right into the rock, you say?
Right into the rock, and also anchored. They are also supported through anchors and cable bolts. At least two of these pillars, main pillars, which is on either side, has even cable anchors going up to 100 meters into the rock, holding them back. This is a huge, phenomenal, how we have to transfer the load from the bridge to the foundation. That's a big challenge, and that is where the major design has gone in, and excavating that also now. Because please understand, these slopes are very steep. Whatever you do, if you use initially the excavators work was very slow, because reaching those points. Then controlled explosives were used. But if you use that, all debris will go into the river and clog the river. So we have to make pits, so that design is also very unique. That means you are catching all those controlled excavated material using explosives, also at different levels, and remove them, not reaching the bottom of the river.
Oh, okay.
And these steps were created, and then the vehicles were also moved, and then these foundation levels were also reached, and then foundations were created. And while doing that, we found that many of these rocks are very porous. So we have to do cement grouting. Cement grouting, large cement bag grouting has been done. Several thousands and lakhs of cement bags have been
give the
put
foundation
in.
a secure
secure and consolidated rock mass. And then rock bolts were inserted. So this is a step-by-step excavation, what we call in geotechnical engineering. As we go, we learn about the material and the situation in the ground, and continue the modified the design.
Okay.
That is how as you go design approach, we call this.
All right. It's an engineering marvel. It's so high, crossing over such high mountain slopes. But from a safety point of view, what has been brought in so that the safety aspect or the safety net is there?
You see, I will start from the foundation itself. Every foundation, enough care is taken and it is designed to very accurately, the very minimum settlements can happen. Differential settlements are also controlled at the site. Next, once you come, the foundations and above the pillar and the bridge deck, there lot of safety features have been introduced, okay, and such that even each component, something fails, the entire bridge will never collapse. So there is a phenomenal, different steps of safety considerations have been considered while designing this bridge.
A feat which is unparalleled even in the history, not just of the Indian Railways, but many railways around the world. Congratulations for this project.
Thank you very much. It is a phenomenal.
So clearly now the focus is, as Professor Sitharam was saying, that it's not just connecting the valley with the rest of the country, but it's connecting the people of Kashmir with the rest of India, the integration that this railway line, once trains start passing through, that process will begin. Thank you for watching. Namaskar.